What's the opposite of division? Okay. So when we solve a single-step division equation, in order to cancel the divide, we do the inverse operation, which is multiply. And yes, I realize these are a particular sports team colors, in case none of you noticed.
Yeah.
This is what this is going to look like. We're going to have some number x divided by another number, call it a, equals b. And the way to solve this is to multiply both sides by what, do you think? Not b. Not x.
X over A.
Nope. Nope.
A over B.
Nope. Keep going.
Working thinking.
Huh? Nope. I don't think I've heard it yet. How did we get this a out of the bottom?
Multiply it by the top.
Huh?
I don't even know.
Hey, this head is
By the top. I still know.
So we multiply.
You multiply X and A.
Multiply both sides by a.
I swear someone said that.
Oh, so sad. I can't.
If you have an a in the numerator and an a in the denominator, they're going to cancel and you're going to get x by itself, right? Some of you think of it as a over 1, which is true. It would just become x over 1, which is just x. So to cancel out division, we multiply. That's the inverse operation of multiplication. Yes? Yeah, like basically, yes. It's like putting the a over the 1 without the 1, because ultimately a is kind of like the numerator, and the a and the denominator will cancel each other out. Or you could think of it this way. That would actually simplify to ax over a if you multiplied it straight across, right? Equals a times b. But the a's would cancel anyways. Okay? But the point is, inverse operation of division is multiplication. First example, we're going to have -4, equals x over 5. All right, step 1 for single step division is to multiply both sides by the variable denominator. Yes, in this case, it is 5. So we're going to multiply both sides by 5. So I'm going to multiply the right side by 5. And multiply the the right side by 5. And what's the name of the property that allows us to multiply both sides by the same number?
Is this reflex?
Multiplicative property of equality.
Question. Were you allowed to put this standard?
Anyway, so the point is, when we multiply both sides by 5, those are going to cancel. We're just going to have x on the right side, and just work this out. What's 5 times -4? -3? Where did that come from?
Huh? You multiply it.
5 times -4 ain't 3, man.
What are you talking about? I multiply 5 and -4.
My dude, Ricardo,
All right. We can take the -20 and we can plug it back in to x if we wanted to. We could do -20 over 5, which checks out to -4. I'm not going to make you guys plug it back in, but that is an option in case you finish a test or something early. All right, let's do another one. Let's do the variable n, which stands for number. N over 20 equals 4/5. Okay? What are you going to multiply both sides by? The variable denominator, which is 20. Right. And just make sure you do it to both sides. Well, there's an easier way to do this. So first of all, let's just go ahead and cancel the right side out. So that's n. The easy way to do this, guys, is also to cross cancel. So we can write 20 as 20 over 1 times 4 over 5. Yes, you can multiply straight across and get 80 over 5, but it's a lot easier if you just do this. 20 over 5 equals 4. Let me just remind you guys why we're allowed to do that. We're allowed to do that based on a couple properties. Okay? First one is multiplying fractions, and the second one is you could switch the 4 and the 20 because of the commutative property of multiplication. But anyways, that's why we can do it. So now we have 4 times 4, which gives you 16, as she said. I'm going to write the problem a different way for the third example. Again, you could simplify this, plug it back in, 16 over 20. It will reduce to 4/5. Now we know there's different ways to write division. So for the third example, I'm going to have -3 equals, say, x again, divided by -1/3. Now, even though it looks weird, you're still going to follow the same steps. I don't teach you guys these steps as if it only applies to certain examples. This is a single step division problem, so it will work. So we're going to multiply both sides by the variable denominator. What's the denominator here? -1/3. I know it doesn't look like a fraction, but look, this is the top, and we have the division sign. This would be the denominator. The denominator is what you divide by, okay? So I know it's not on the bottom of a fraction per se, but the way it's written, it's dividing by -1/3, so that is the denominator. So we're going to multiply both sides by -1/3. Again, we're multiplying by that denominator. And notice, it's still going to cancel that right side out because you're dividing and multiplying by the same number, so that will go away. So you're just going to have x on the right, and then all you have to do now is just do -1/3 times -3. Does anybody know what that is? Okay. Now you still have the negative, right?
Only -1.
No, 1. It's 1.
It'd be -1 times a negative, which is a +1. Think about it. It's a negative times a negative, okay? So it's got to be positive. And we can go ahead and, if we wanted to, we could plug that back in. If we plugged in 1 for x, it'd be 1 divided by -1/3, which would be the same as 1 times -3 over 1, which gives you -3, which is what we had on the left-hand side of the equation.